That's the energy. Oh, this is easy.
Yeah.
That equals. Okay. 37.5. And then work equals FD. So we can divide this by 2,800. And then we get the force.
Yeah. So this is a work energy principle, right? Work equals to dot. Well, the original one is work equals to dot K. And actually, you can also write in work into dot E, which also making sense, right?
Yeah.
This can contains like all the other energy form. That also works too. Of course, this comes from like conservation of energy, because you can consider work somehow on a level it's energy. That means, for example, we eat something, it's always energy, right? We eat something, and then it transform into the work that we can do with our exercises, sports, right? So obviously they can transform from one to another. 37. That's 37. I think you'll be okay.
Constant rate. Wait, oh, I didn't clear.
We don't have to do 37. I think 37
Okay.
will be okay. 36. Have you done 36 before?
No.
Let's do 36. This is level 1.
You're experimenting with the. I can't see it. Simple spring block oscillator that's being causing key amplitude A. The block is attached to Oh. Oh, it's this one. Slightly slide. On top of the original block. Probably the maximum displacement, right?
Mm.
So you have to find the force of the. Uh,
Which one you want to choose?
is it A?
Yeah.
Okay. I think we
Is
would
it
sign off on like the equilibrium, and then like the friction has to be
is it making sense? Eh?
yeah. Yeah.
Okay. First we'll probably make D and D. It's between A and C. But this is making sense, right? 36?
Uh-huh.
35.
The spring constant. The spring is 3 centimeters. Okay. 150 times that's 3 centimeters. So 0.03 equals that's 4.5 newtons. How fast can it punch a pinball with a mass of 0.08 kilograms? Equals mass times acceleration. Oh wait, it says how fast can it punch it? Then all the answers are in meters.
Hmm.
Um, 4.5 newtons, and then you have 0.08 kilograms. Then
You can draw the picture. If this is your force, right?
uh-huh.
But that force only works
Oh, do I have
in
to
the
do momentum?
well, you can do the force, but you can imagine the force only works in the very beginning, right?
Yeah.
Later it's not that well, because 3, 2.9, 2.8 is going to decrease, right?
Mm.
So if you want to find the force is changing. It's kind of a little difficult, right?
Mm.
If this thing is kind of like this, right?
Yeah.
And then because the force is getting less and less, but they are still like a how about I think about energy?
MV squared equals. Wait,
The energy,
V-
if you think of the force, is a little bit changing. But if you think about the energy, I can find the initial energy, right? The energy doesn't change. The total energy doesn't change, right?
initial energy. But you need. But don't you need like distance for? The, oh wait, you have the distance at 0.3. the
1 over
force.
2 kx squared.
Oh, yeah. 1 over 2. And then 0.03. Oh, I see now. Divided by 2. Wait, that's not K though. That's K is 150. 75 plus 0.0675 1/2 0.08 b squared equals 0.06. B. It's A.
Yep.
1.3.
So energy is okay, right? Energy level.
Yeah, energy is okay.
If energy angle is well, especially it's working when your force is changing and your velocity is changing. Okay? So I don't really have to think about all the process of changing force, right? Changing force, changing acceleration, right? Kind of forgot what's the pinball. You know the pinball machine, right?
Yeah.
Kind of forgot that. So that's why we don't have to think about those like potential. I mean, gravitational potential energy because it's a table, right? It's always the same potential energy, like a gravitational potential energy. I don't have to think about that, right? And some people are not familiar with pinball machine, so they have difficulty to think about is there like 34.
That looks like a large cylinder. I think we've done these.
Okay, this which means this is a previous test, 2019. Yeah. Okay, now we can go to 3. I finished the first one. Do you have any problem with the practice this 3?
I can. $24.
This baseball is traveling at this horizontally when it is struck by a baseball bat. The baseball leaves the bat at 50 and back in the direction it came, but at an angle of 40 degrees above the horizontal. What is the magnitude of the impulse imparted the baseball? Can you draw the picture, the phenomenon? There must be a x direction and a y direction then, right? There's an angle.
50 meters per second back in the direction it came from. Does that mean this component is 50?
No.
Oh, does that mean this part's 50 then?
Is the entire thing is 50. Hmm. Well, I can do impulse, I can do ft, right? But since I don't really know f, I might use delta p, right? But when I think it as a vector, right? So I must have a x direction impulse, and I have a y direction impulse, right? And since they ask us the magnitude of the impulse entirely, so I guess in the end I have to use Pythagoras to find this.
Mm-hmm.
Does that make sense? So now let's find it separately. In x direction, before is 40. Now is what? What's the component? If this is 50, this 40 degree. So that's 50 times cosine, right? Cosine 40, right?
Mm-hmm.
So in this thing, horizontal direction, my delta p, or maybe delta px, x direction is this is negative. I will use I can have to call this one negative, right? Negative, because this one is obviously positive, and this one is negative, right? So it's negative 50 cos 40 degrees. Does that make sense? Minus 40, right? Does that make sense?
Mm-hmm.
And so this is my delta px squared, right? This is delta px, right? Does that make sense?
Yeah.
And all I need is delta py then, right? In y direction, originally it's 0, so that's well, it doesn't really matter the positive negative then. So you have this in here, so it's 50 times sine delta py is 50 sine 40 degree minus 0, right? It doesn't really matter the positive negative, right? But if we use x and y, then this is negative, right? It doesn't really matter, it's okay anyway. So plus delta py square, right? Does that make sense?
Mm-hmm.
Oh, of course I have time m time all this, and m time all this, right? Oh, I can get m, like a common factor out there, right? And this is well, maybe not here. And get m, I can do the velocity thing then. Does it make sense?
Yeah.
Generally, it's this method. Does it make sense?
Okay.
24, where it stopped you before? I remember you have a good understanding about the different directions, x direction, y direction.
Oh, wait, I think it was just like the impulse. Wait,
So they ask impulse. I don't know ft, so I have to use delta p, right?
yeah.
But
Okay.
it's obviously have two directions. And both momentum or like Well, because ft equals to delta p, so this is a vector. This is also a vector, right?
Mhm.
So I can use vector adding, eventually use Pythagoras to find it. XY direction is easy to help me to find it. Is 24 okay?
Yeah.
So you can see different angle. When you see this angle, you know it's probably XY system, right?
Yeah.
And in each direction we use ft equals to delta p, and then you have a vector adding there. Which one is next?
31.
31. Three masses. Is this 31? Yeah.
Yeah.
Three masses are attached to 1.5 long massless bar. One is 2, and is attached to the far left, and then this 4, and then 3 is 4. At what distance from the left bar could we throw the bar horizontal? We learned the torque, right?
Yeah.
So basically the torque have to balance, right? And we also learn equilibrium for rotation, right? You remember? So when you basically balanced your clockwise and anti-clockwise torque should be balanced. Does that make sense?
Uh-huh.
So let's find a pivot. Any pivot is okay. This is the center. We didn't learn center of the mass, right? Have you learned center of the mass before?
No.
But we don't have to use it. We can still use at what distance from the bar, left side of the bar, can a string be attached to hold the bar off horizontal? So let's say if this is the pivot. So actually I can find any pivot, but this one is just if this is the pivot, so this thing is gonna make them rotate, right? This also make them rotate, right? And then can I find all the torque? This torque is gonna be 0, right? So this pivot, because go through the gravity go through the pivot already. I can use 4 for this one. 4 times 0.75. Of course, I time g. 4g times that, right? And plus 4g times 1.5, right? This one is 4g times 1.5, right? This is the distance. Right? Remember FL or FR perpendicular, right? Does that make sense? This all make them like rotate clockwise, right? And they at what distance of the from the left or can a string be attached to hold it? Let's say if it's here, there's a string, right?
Yeah.
So this one should balance all that, right? So for this thing to balance, I have to balance all the forces.
Yeah.
So if I balance all the forces, I have to use this F equals to all the mg together, right? All this mg together. Does that make sense?
Mm-hmm.
Basically, it's 10 g, right? Does that make sense?
Mm-hmm.
So this is 10g, this is F, time the new, this one is x, right?
Yeah.
Time the x. Oh, I think I can find this one, right? X is the only one that we don't know. G simplified, right?
Yeah.
Is it making sense?
Yeah.
This is using the knowledge of equilibrium of rotation, which means sigma F should be 0 and sigma torque also should be 0. Does that make sense?
Mm-hmm.
The 31, okay?
Yeah.
What stopped you, 31?
Just the this stuff.
Question we never seen it before, right?
Yeah.
Yeah. So, but do you have a little feeling about its probability rotation?
Yeah.
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 Yeah. If you have some kind of a rotation feeling, then you can always use sigma torque, which means clockwise equals to anti-clockwise. Sometimes we write this one before clockwise, anti-clockwise before. This is also okay. But you should also find sigma f is 0.
Okay.
So we just kind of have a system equation. This is very common in this kind of situation.
Okay.
Any other questions?
I think that's it.
Did you do like a free response?
Oh no.
No, we can do free response. No. Here.
What is the displacement from object from time 0 to time 6? Velocity over time. This is just find the area. And like dividing. Okay.
Mm.
This is 1/2, 2 times 1. This is 0. This is 2. 1, 2. This is Wait, is it? Yeah, this is 3. Wait. Um, 4.5. 6, 8, 9, 13.5 meters.
This is a 3. Wait, I understand the first part. This is a 3, right? You said
Yeah.
this is 1 time, because this is 3, right?
Mm-hmm.
But when we say the area, is it the area with the graph? This is the area of the graph, right? And exit and the initial and the final, which means it should be this area for the second part, the 2 to 3. Does that make sense? It's a 2 then, right?
Mm-hmm.
So because in the beginning, what we do is basically this, right? See, it's the graph and the x-axis, right? And the initial value, well, initial vertical line and the final vertical line, right? Does that make sense? So that's why this should be this 2, right? Although they wrote it here, but you should consider it's in here, right?
Mm-hmm.
3 to 5, 3 to 5, maybe, or 3 to.
What time did the object leave?
Wait, it's not finished yet. So if this one is true, how about this part? Did you find this part entirely? What is this then?
Oh, that's 4.5. I think that's entirely, but I'll find just the top part. So then that's this is 3. This is 2. Uh, this is 2.
The next part should be finding this one, right? 2, yeah,
Yeah.
this one is 2. And 5 to 6?
5 to 6 is this part here.
Wait, with x-axis, so with this one. I mean, this should be the area.
Oh,
Right?
okay.
Always with the x-axis. So this
Oh,
one, oh, this one just looks like x-axis, but it's not, right? X-axis is here.
oh,
That's a
okay. I
trick.
see now.
That's a
I
trick.
see now. This is 1. This is 1. 1. And then it's 1/2.
Yeah. And it's also a little special because it's below the x-axis, right? Which make it so special. This one is negative. Does that make sense? Which means you turn around, right? Does that make sense?
Mm-hmm.
Which means when you add it, you should add this one as negative 0.5, right? Does that make sense? Everything
Yeah.
else, as long it's above, well, basically, as long as the graph is above the x-axis, it's always positive, right? But as long as you go down below the x-axis, it's negative displacement, right?
Mm-hmm.
So you should all add all this. Wait, then let me see the 1 to 0 to 2. 0 to 2.
This is
0 to 2
this
should
is
be this,
2.
right?
Yeah. And yeah, it's 2, and then the top is still 1. So this is 2. Oh, and then so you add it all up, 6. That's 5.5.
Wait, let me see. Isn't this a trapezium?
Yeah.
Oh, if you say this is 1, this is 2, then that is a 3 anyway. 3
Yeah.
doesn't, it's not changed, right?
Yeah.
So which means you did some calculation wrong before.
Oh
right?
wait, 7.5.
Wait, it's 7? You mean the
This is
final
just
result?
yeah.
Wait, I think it's a 3 plus 3 plus 2 minus. Wait, let me think.
Minus a half.
3 plus 3 plus 2 minus 0.5, which is. Okay. But I feel something is not that adding up. 3 to 5 is 2, yes. And 2 to 3 is 2 to 3. Wait, 2 to 3 is 2. This part is 2. See, I marked this part 2. See, it's not, this part is not included. It's only this part. So this is not a 3, this is a 2, right? Because it should be getting it with the x-axis, so this part is not included. Only this part. Is it? Does it make sense? So I think it's 6.5, right? Then
Yeah.
okay. So now we should not just say it, because before we just say it in a short form, saying area is a displacement, which is not exactly right? We should think about what kind of area, right? Always with the x-axis, always with the graph, always with the well, x equals to x1 and x equals to x2, right? This 4 part shaded region area, right? Very easy to get the wrong area in the beginning. B. B now. Speed is increasing.
Oh, just 1 to 2, right?
1 to 2. You mean 0 to 2, right?
Yeah, 0. Yeah.
If they say the speed is increasing, this part is not changing at all. What about this part?
That's decreasing.
Decreasing. But when you decrease until here, what will happen in here?
You move backwards.
Yeah, you move backward, but what about the speed?
Oh, speed is it's increasing.
Yeah, that part is also increasing, right?
Yeah.
Sometimes I get confused. I just mark everything. See? That's a -1, -2, -3, right? So it's increasing, right? The magnitude of the velocity is changing, right? Absolute value is changing. So 2 parts, right? 2 intervals here. C. So let me emphasize something. B here is one of the, I think one of very important key for physics is you have to think about the real situation, unless it's something that you really sure. Does that make sense? You have to think about a real situation, then you can probably think about what's this one. Make sense in each interval. C, let's do C. Position versus time.
Position versus time. So time 0 goes to 0.
But you think first here it doesn't change? Oh, I think what you meant is acceleration doesn't change, but this is not acceleration.
Oh.
This is position, which means is a displacement, right? It starts from x equals to 0.
So then it starts from here. And then
You're definitely increasing at least, right?
Like if its velocity is like that, that means distance, average distance. Oh, and that's the slope then.
Then this is something that I hope you remember. This, if it is velocity, and this quadratic thing. I mean, this means your velocity is increasing, right? This also means slope is increasing, right?
Yeah.
So yeah, the first part. And also start x equals to 0, so it starts from here.
Oh, I see. Oh wait, yeah, it makes sense. Okay. And then it would be like constant slope for 3 to 4.
Yeah.
And then it goes down like that.
Oh, you probably shouldn't decrease that because should be the tangent for that one. Is that mean? Because this final velocity is your final.
Oh, it's okay. It makes sense. Yeah, yeah. And then
then you can you imagine this? If this one is a quadratic, this one probably is another quadratic, right?
yeah.
It's also like a same acceleration. I actually, without the calculator, we haven't proved yet, but let's try to remember that. Oh wait, this one also quadratic, but the velocity decrease, right?
Mm-hmm.
This is a position displacement. You don't have decrease this. When velocity decrease,
then
which
okay,
shape like this. Right?
Yeah.
This is a velocity decrease. Right?
Okay, makes sense. Yeah, yeah.
So remember, we find this one. We also find the other one? This one, right? This is decreasing velocity. So if this one is v displacement, this is also v like this, then we say it's like this, right? The straight line, and then the other one is a quadratic. But and then from 3 to 5. Oh, this part is 3 to 5. This is 3. This is 3. I think this is 2. This is 3 to 5. And then this part. You should go to the different direction of the displacement, right? which means you should decrease your position, right? Like this. Does that make sense? And also because they have the same slope, which kind of means that same quadratic one. Does that make sense?
Yeah.
Yeah, so this one we can try to remember. If it's like this, it'll be something like this. Oh, sorry, 1 second. Sure. You can take the another question. Question 2. Okay. Oh, sorry about that. It's just they're only 4 years old. Oh, tension, normal, friction. Wait. Okay. Sure. How about B?
When frictionless massless pulley determine the acceleration of velocity relation. Acceleration. Hmm. Hmm. Okay. So then. Okay, so then that's the MG 3. You have the 3mg and then this part you have the FT. Extension. Wait. Oh, right. Like theta. Okay, so this is wait, wait, this is FT sine 30 if sine theta, right? It's sine theta, right?
Uh,
Right.
you try to remember the formula, right? The formula, if you try to formula, the formula that we have is for gravity. One is for this, is mg sine theta.
Mm-hmm.
And this one, component of the gravity, perpendicular to the slope, which is mg cos theta. Is that what you asked?
Yeah.
Remember, this is only gravity.
Mg sine theta. So it's the tension is the 3mg, right? From the
Well, the tension, we don't really know if the 3mg. And we can also kind of prove that it's not 3mg, because if your tension here is 3mg, and because then the tension in every part for this kind of situation is also 3mg, right? It is 3mg in here and 3mg in here. It's balanced, so it's not moving anymore, right?
Oh, so then oh, so that's all gravity. Mm.
So you kind of have to find that tension. Tension is unknown, but we know the tension here is also the tension here, right? Because it's not, there's no slack in there, so the tension is the same. It's been a while. Let me remind you something. It's in this kind of situation, it's called two-block system, right?
Mm-hmm.
Two-block system. There's another kind of name for this. Let's just call it two-block system. And one block can have an equation. The other block will have another equation. Is it the equation about Newton's second law? Or the other one, they both of them together can be formed into a like a system. Let's just do this one first. If I talk about 3m, because there are a lot less force in there, let me talk about that. F tension minus 3mg, that's all the sigma F, right?
Yeah.
Or F net. And this equals to 3ma, right?
Mm-hmm.
The good part is this A is also this A, because they are in a same straight line, right? Down the same, no, not same straight line. Well, just down the same string, right? So the acceleration should be the same. Velocity also should be the same, right? Distance, displacement, or distance all be the same. Right? And for this one, I also have a mg, you can imagine, right? Does that make sense? Newton's third law. And all I have to find is his sigma F. His sigma F is, in this direction, you have a F tension. And you also have a F friction, right? But you also have a mg's component, right?
Mm-hmm.
So let me get this in this direction for this one. Let me draw again. This is F tension, and this is the friction. But there's also a component, right? I don't have to think about this two directions. This one balanced with this one, right? So all I need is this 3. So I add all these 3 together. One is in this direction, the other one in the opposite direction. So I assume this one is bigger, right? Because you basically have to walk in that direction, right? So I'm using F tension, should be the same F tension in here, same magnitude, minus mg sine theta, right? This one is mg sine theta, the component from gravity, right?
Mm-hmm.
And the other one is friction. Oh, friction is what? Mu Fn, right? Is it? Mu Fn, right?
Mm-hmm.
Because they say mu to be known. So mu k time Fn is what? I guess I have to use this after all. This is Fn. This is what?
Uh-huh.
What is this force?
Oh, that's
Component of gravity, because I basically resolve gravity, right? But this is another component, which is mg cosine theta. Does it make sense?
Mm.
So in there, maybe I have to say 3 equations. So Fn equals to mg cos theta, right? So mu k times mg cos theta. Does it make sense?
Mm-hmm.
And this two will form a system of equations that I can resolve, that I can totally get rid of Ft, right?
Mm-hmm.
Well, I can, let me think. I can minus that, I guess. Yeah. I can minus that. Minus would be, which one is greater? That one is greater. Ft minus, oh, I wrote one thing wrong. See, that's right, there's something wrong. Positive negative is actually kind of important. There's something wrong with my equation 1. Can you see it? Because I haven't thought about which one is greater. 3 mg should be greater, right? Otherwise, you can't really make in that direction, right? The only motion you can make is in that direction, right? So 3 mg should be greater. So I'm using 3 mg minus Ft instead of this. Does that make sense?
Mm-hmm.
3 mg minus Ft equals to 3 ma. And then I can cancel them out by adding equation 1 and equation 2. Is that okay?
Yeah.
Then Ft is gone. So 3 mg, because it's adding, minus this and minus this, equals to 3 ma plus ma. So eventually you have 3 mg minus mg sine theta minus mu mg cos theta equals to 4 ma. Does that make sense?
Mm-hmm.
This also works as this part as system. See, this is the driving force, right? If I consider this 2 block as one system, this 3 mg is the only driving force that I have. All the other one is the preventing force. See, this is preventing me doing that motion, right? And this also friction preventing me, right? So that's why I should minus. And 2 blocks together form a 4m system. Does that make sense?
Yeah.
So this is called system method, right? Does that make sense? So it's basically it's 2 equations adding together or subtract each other. So with this I can find A, right? I can just divide it 4m, right? Does that make sense?
Yeah. Okay.
Yeah, just divide it by 4m. And m is actually simplified. Yeah. So eventually just 3g minus g sine theta minus mu g cos theta over 4, right? That's A, right? Does that make sense? Is B okay?
Yeah.
So what should we be careful about B?
The tension.
Newton's second law, right? Basically,
Yeah.
sigma F equals to ma. But you have to use it twice, right? Does that make sense? Or you know, use the system, which is a little difficult to do it sometimes. You can find the two equations about this. And then just solve it in a normal way that will solve system equation. Say B, I mean C. How about C?
When is the distance shown by the block 3 seconds after being released from rest? Wait, so then
Oh, and also one thing, there is another thing I have to mention about B. B also you have to be very familiar with this. Let me use gravity. This is mg cos sine theta. This is mg cos theta, right? If you're not familiar with this, you have to use some time to prove it, right? Does that make sense? And also we actually use the XY system kind of. This is the X system, this is the XY system. You have to balance the normal with the component of gravity. Let's go see.
it's minus the mg sine theta. Sine theta is root 2 over 2. So that is a friction. Friction is 0.3 g cos theta. Root 2 over 2.
Wait, do you need the B's answer? Actually, when we use B's answer, that'll be probably easier.
Yeah.
Yeah, that is the 3g minus the mu g cos theta and minus g sine theta. All this divided by 4. Or you can get the g as the common factor after. So with this, you can just find acceleration directly, right?
Yeah. 3
If you
times 10.
Yeah.
0.3.
I don't think you have to do it. Just it's okay. Say
Okay.
we already have an acceleration, then what to do with the distance?
We have the time acceleration. We can just do the acceleration times the time, and then you get the speed at the end. Oh wait. Oh wait, you have to do big 5, right?
Yeah, because this is totally uniform acceleration, right?
Yeah, you need to do 5.
If we find acceleration, normally we always use big 5 because it's the
Yeah.
constant acceleration.
Yeah. Okay. Yeah, makes sense.
Which equation you want to use?
It's the need the x. Oh, you can do the. Wait, we have the x equals x initial plus v initial.
Oh,
Wait, yeah.
this one?
Delta x equals
Yeah,
v zero d plus 1/2 at
yeah. So v0 is what?
from 0.
Yes. Then everything is substitution. T3.
Oh yeah, I need okay. Yeah.
So previous answer is always a lead for the next question normally. 3.
250-gram volleyball is dropped from 2 meters about. What? 250-gram volleyball is dropped from a height of 2 meters and bounced to 1.8. The volleyball is returned to a height of 2 meters, and the 60-gram tennis ball is held centered slightly above. Oh. Oh. Okay, we can do the energy. This is 0.25 times 10 times 2. The potential energy you drop it, and then it only comes back to 1.8, and so that's like 1.25 times 10 times 1.8, which is 4.5. So you lose 0.5 over 5, which is percentage. So 10%.
Yeah.
And then it
10% loss.
becomes
Yes.
heat, turned into heat.
Yeah. Would be
0.2 seconds from the average force on the ball during this. If it took 0.2 seconds. What's the average force on the ball during the bounce? Zero point 0.2 seconds. The ball bounce. It's like impulse, right?
Yep. If you find average force, I would have used impulse.
F delta V equals M delta T, right? Do we know delta V?
Not yet.
Well, no. Uh, Wait, do we need to find delta V, right? We do, right? 'Cause-
Yeah, we do. But we don't have thought of it directly, but you can find V final minus V initial, right? In this process. Can you find the V final and V initial? I mean, for this 0.2 seconds, V final and V initial.
Final. V final has to be hmm. Bounce. If it bounces, that means. Oh wait, we have the energy, right?
Yeah.
So initial is 1/2. We had okay. Initial is 5 joules and 0.25 v squared. Uh, so 40 equals v squared. V and a V initial. The initial equals 6.325. And V final it's 4.5. Wait, okay. 125, 4.5, 36, equals 6. So delta V is 0.325. And divide that by 0.2. Multiply that by m. 0.325. Divide that by 0.2 seconds. Multiply that by 0.25. That means F equals 0.4 newtons.
0.4, right?
Yeah.
Yeah, that's not too little.
Too little?
Uh,
Wait, okay.
So how did you find that? What's this one? This is V equals to square root 2gh. Yeah?
I had square root of 40. Wait, that's square root of 2. 40 is the wait. Wait, square root of 2g. G 10 times. Yeah, it is 2gh.
Yeah.
And then
So
the
H
second
is
one.
2, right? G is 9.8.
Oh, I didn't use 10, not 9.8.
Oh, sure.
I don't think I should change it really too much.
Yeah.
Um,
And also because in previous question A, there is saying 10% energy loss, right?
yeah. Yeah.
Can I use energy? Do you think that 10% is certain?
No. This is
Well, you don't have to think of whether it's certain, but it's a 1.8 anyway, right?
yeah.
So if I use square root of 1, well, let's still use 2gh. This time h is 1.8, right?
Yeah.
I can find another velocity, right?
Yeah. 2 times 10 times 2 times 10 times 1.8. It's 36. Yeah, it's still the same thing that I had though.
It's 5 point what? You say 5 point what?
It's 6. It's 6.
Oh, let's say 6. Oh, I think you probably got wrong with the direction. Are you using this 6 minus the other 6 thing?
Oh, you're right.
One is positive, the other is negative, right?
Wait, so it should be negative force?
Well, sure. If you think about this as positive, your force is negative, of course.
Wait, if the falling is positive, then the force back is negative, right?
Which one is it? This one is 6, right? Let's use that 6 as the final one is the, let's
Positive.
use this one as positive. It doesn't really
This
matter. It's okay
6
anyway.
The 6
6 minus that negative 6.1.
6.325.
325. Yeah, that's more like it.
That's delta V, right?
Yeah.
Okay, so then oh right, yeah, oh that's why I did it wrong then. Okay. Multiply that by mass 15.4 newtons.
Yeah.
How high does a tennis ball bounce? There, this is 15.4. The tennis ball collides with the volleyball just after the volleyballs bounce off the ground. Just after the volleyball. Okay, so then it's like a
The collide
that
in the
means like
air, right?
that means the volleyball transfers all of its energy to the tennis. Wait, no.
Kind of. Conservation
Oh,
still happens, right?
so then that means the volleyball gives the tennis ball 15.4 newton for the energy.
Hmm. I think energy angle is probably easier.
Oh, right, because it continues up to some. Wait. Oh, this is after. This is a different thing.
Hmm.
Okay. Okay, this makes sense. How high does it go? 1/2. Okay, we know it starts with the 5 joules. 5 joules equals um wait,
Because that's 0.3, we probably can find something.
yeah, wait.
Conservation also happens.
You do the
I can still
mg
use that v equals to square root 2gh thing, right?
equals oh I see square root
That still comes from conservation
times
energy.
10 20 times 0.3. That equals oh, and then you have the energy for that went to tennis ball. Square root of 6. Square root of 6 is 2.45 almost. And then so we start with 5 and then we minus 2.45. That must equal 2.55 joules into the tennis ball. And you can just put this into the MGH, right? And get the height. No error resistance.
Mm.
Do we have the mass of the tennis ball? 60. 0.06 times 10 times 8 divided by 0.6. So let me do that. 0.55 by 0.6. H equals 4.25 meters. Yeah, 4.25 meters, right?
4.5. Are you using momentum conservation?
Oh,
If you don't use that, I think it's pretty difficult to find in this one. I know conservation of momentum is a little bit because you have to consider that they are very. None of them have huge mass, right? And the other one is a tennis ball, 60 G.
okay. So then conservation of momentum. Okay, conservation of momentum. That means M1V1 equals M2V2, right?
Right, momentum before it should be the one with the what is the two balls in tennis and volleyball.
Uh, wait.
Also, do you know what it means by like this one? They have indication in here, slightly above, which means after the dropping, their velocity should be approximately the same. Does that make sense?
Yeah.
So you should use M1 V1 plus M2 V2. This is one is the volleyball, the other is the tennis, right?
Yeah. That equals to
That equals to the M1 V1 prime and M2 V2 prime after the collision.
so V1 and V2 are basically like the same, right?
I can't remember. I think I remember you said something about a 6, right? I think this one should use that 6.
Oh, 6 was the was 6 the velocity?
Wait,
Oh yeah,
there's a
6 was the
6,
velocity.
6 is the. I think
6
it's
is the
6.
velocity back up.
Yeah, then I should use this one, right? Does that make sense?
Yeah,
You're going in there, that's a 6, right?
Mm-hmm.
And then plus, and also when you do this, it's probably better to use 9.8. And the other one, let me think, the other one I should use 0.06 times, what's V2? V2, how do I find V2? V2, that's why I say slightly above that. Everything drop at the same distance, free drop, no air resistance. So it should be the one that you find like a 6.3 something, right? And should it be negative, right? Negative 6.325, you said?
Mm-hmm.
Does that make sense?
Yeah.
No.
That's
And then it equals with what's after it? 0.25 times, what's the new velocity for this? This is the volleyball continues up over 0.3. I think from this, I can use V equals to square root 2g8. This comes from conservation of energy. I can find this velocity, right? Because you go up 0.3 meters, so I can find your initial velocity, right? By V equals to square root 2gh, right? Does that make sense?
Mhm.
2 times 9.8 times, or you can use 10, and 0.3. Does that make sense?
Mm-hmm.
So let's use that V in here. Plus, does that make sense?
Yeah.
Plus something that we don't know. 0.06 times something, let's say V. Okay? Let's say Vx. The unknown. This is the only unknown one, right? Does it make sense?
Mm-hmm.
And then I can find this V, right?
Mm-hmm.
So the tennis ball have this velocity, and then they will go up, right? And the tennis will go up, right?
Mm-hmm.
And then again, I can use V equals square root 2gh. You probably should use m1 mv square equals to mgh, right? V equals 2gh.
Yeah.
And I can find that h, right? Because I have that V, right? V here is there, right? Did it make sense?
Yeah.
Oh, this one is tricky. Is it making sense?
Yeah. Wait. Yeah. Yeah.
It's difficult to think about conservation of momentum, right? But it's a collision. Normally, whenever a collision happens, we use that.
Mm-hmm.
Does that make sense?
Mm-hmm.
So we have to use. I think if without conservation of momentum, we can't really do this, right? bit difficult though. So is it okay? So
Yeah.
remember, collision happens, probability momentum conservation happens. Okay? And you should use total momentum before is equals to the total momentum after, not m1v1 equals to m2v2 thing. I used this before. See other. We call it momentum conservation, but the reality, the truth is actually is what? Is the momentum, is the total momentum before the collision of all objects equals to the total momentum adding together after the collision, right? So it's never this, right? You can use P total before equals to P total after. Yeah, that may be okay, right? Does that make sense? Okay. This is 3. We still have 4 and 5. So the homework would be the 4 and 5. Of course, the question that we did. I think you should really redo all this. It's been a while, so it's better to do it all.
Okay.
And then just go on with the practice 3 and 4, 5.
Okay.
I mean that free response 4, 5.
Okay.
Have a good day.
Bye-bye.